So let's move to another one because these problems are fairly difficult. And what we're going to do is we'll start with our equation. And again, we're going to complete the square. And from there, we will have vertex form. We'll plot our vertex, and then we'll find those intercepts. Or once we have vertex form, we can just plot a point on either side of the vertex and then use symmetry to find a third point. So it really just depends the scenario. But the most accurate way to do this is to find the vertex and then plot the intercepts as well. So we need to start with completing the square. And remember that the coefficient on x squared, we want it to be 1. So we're going to have to factor out this 2/3. And this one looks like it'll be a little bit messy. And again, we're going to isolate the x terms and kind of move our constant off to the side. So we're going to factor out this 2/3. And so this would be x squared. And when you're factoring something out, you're essentially dividing. So we're dividing 4 by 2/3, which is the same as multiplying it by 3/2. So that's 12 divided by 2, which is 6. So we'd have plus 6x, and I'm going to leave a gap, and then plus 4 on the outside. And you can test this. If you re-multiply the 2/3, you'll see that you get back 4x here. And again, we want to compare this to our formula for completing the square, or for perfect squares, I should say. And x plus a squared would expand to x squared plus 2ax plus a squared. So we can figure out what a is, because twice a is 6. So let me just write that down. That 2a is 6, or in other words, a is 3. And so the number we have to add to actually turn this into a perfect square would be a squared, which in this case is 9. So we're going to add 9. Now, we didn't just add 9, because we added 9 on the inside of this parentheses here. But really, this set of parentheses is multiplied by 2/3. So we didn't add 9, we added 9 times 2/3. And 2/3 of 9 is 6. So we really just added 6 here, so we have to subtract 6 to essentially cancel that out so that we don't change the equation. And from here, this will be equal to 2/3. And now this is a perfect square. And we know the a value is 3. So we can just write this as x plus 3 squared. And then plus 4 minus 6 would be -2. And I encourage you, pause the video, re-multiply this out, and prove to yourself that it is equal to our original equation. So from here, we found the vertex. So our vertex is the x value that makes this expression, this first term here, equal to 0. And so that would be -3. And since the x value of the vertex is -3, when you plug this in here, it would essentially make this entire term 0. And so the y value of the vertex would just be -2. So with our equation, we know the vertex, and we can also figure out the intercepts. So let's do the y-intercept first. So that's when x is 0. So if we plug in 0 for x, then our y value would be 2/3 times 0 plus 3, which is just 3 squared. So that would be 9. And then we'll subtract 2 from that. So 9 divided by 3 is 3. So this is just 3 times 2, which is 6. So we get 6 minus 2, which is 4. So we know our graph goes through the point 0, 4. And we could also find the x-intercept. So for the x-intercept, that's when y is equal to 0. And so we're going to set this equation equal to 0 and then try and solve it. So let me make a little bit more room for that. We'll work this over here. So we have that 0 is 2/3 x plus 3 squared minus 2. So we'll add the 2 to the other side. We've got 2/3 x plus 3 squared. We can multiply everything by 3 and then divide by 2. Or in other words, we can just multiply each side by the reciprocal of this, 3/2. And by doing that, we'll be able to cancel out the fraction on the right-hand side. And on the left-hand side, the 2's cancel. We just get 3. So this is now 3 is x plus 3 squared. And now that we've solved it for the squared expression, the perfect square, we can take a square root of everything. So when we do that, on the right-hand side, the square and the square root cancel. So you just get x plus 3. And on the left side, you get plus or minus the square root of 3. So we just took a square root of both sides. And solving for x, we'll subtract 3 on each side. So x would be minus 3 plus or minus the square root of 3. And the square root of 3 is irrational, so we'll have to approximate that. We can just say that it's about 1.73. So we really have, I should say, approximately minus 3 plus or minus 1.73. And let me just make a little more room. So minus 3 minus 1.73 would be minus 4.73. And when we do minus 3 plus 1.73, that would be minus 1.27. And with all this information, we can start plotting our points now. So we know the vertex, that's at minus 3, minus 2. So let me write that down. So we can just say the points on the graph. We know the vertex, I'll call that V. That's minus 3, minus 2. We know the X-intercepts. That's going to be when y is 0. So minus 4.73, comma 0. And minus 1.27, comma 0. And then we also found the y-intercept. So that's when x is 0. And for that, we found the y-intercept was at 4, or had a y value of 4. Excuse me, let me scroll back up. So 0, comma 4. And with all of this, now we can actually draw a picture. So let me draw a coordinate plane. I'll move over just a bit and scroll down. And let's start plotting these. I'll use blue. So the vertex is at minus 3, comma minus 2, so that's right there. And we know the quadratic is going to be symmetric about this vertex, so it'll be a mirror image on either side. We also have the point minus 4.73, comma 0, so about right there, and minus 1.27, comma 0, about right there. We also know that when x is 0, the y value is at 4, and we can use symmetry to actually find a fifth point, since notice that this point right here is 3 points to the right of our vertex, of this axis of symmetry here. So if we go 3 points to the left, it will also have a y value of 4. So that point would be there as well. And from here, we can now just connect everything. And this will give us a pretty good approximation of what the graph looks like. Now, of course, if you use a computer program, it will draw it perfectly. But when you're drawing it by hand, having the vertex, both the x-intercepts and the y-intercepts will give you all of the information you really need to get a pretty clear sketch of what's going on. Now, like I mentioned in the previous problem, if you're using the Khan Academy exercises to graph these, you really just have to find the vertex and then plot one other point. So whatever point is easiest, sometimes the zeros where it crosses the x-axis, those are easiest, but a lot of times these are irrational numbers, so it's going to be hard to graph that perfectly. But you could, in theory, just pick, like let's say x equals minus 2 and just plug it into the equation. And if it's a nice clean whole number, you'll be able to graph that point, and the interactive grapher will just fill everything else in. So that's another possibility if you want to simplify your work. But when you're doing this on paper, you really should try and be as accurate as possible by drawing the vertex and the intercepts.